denominator it is a prime number, if the denominator it is a prime number, then format this will become remainder of quotient function of a prime number will become a power p minus 1 divided by p equivalent to 1. A and p are co-prime to each other. A and p are co-prime to each other. P is nothing but a prime number. 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 This is very, very useful wherever the negative remainder is failing. Examples. First question. Remainder 1. 3 power 6 by 7. 3 power 6 by 7. First check whether the denominator it is a prime number. 7 is a prime number. 7 minus 1 is 6. So answer for this question is nothing but 1. Answer for this question is nothing but 1. 23 power 12 divided by 13. 23 power 12 divided by 13. A power p minus 1 divided by p. It is 1. If it is 13, 13 minus 1, it will be 12. It will be 12. I hope the idea it is clear. 9 power 37. 9 power 37 divided by 19. 9 power 37 divided by 19. If you use a negative remainder, 9 square, 9 cube, we have to find out which power of 9 when divided by 19. I will get plus 1 or minus 1. But by using Fermat's theorem, directly you will get the answer. If the denominator it is 19, 19 minus 1, 18, 18 multiple till 37, 18 2s are 36, remaining 9 power 1 divided by 19. These are nothing but 1. 1 into 9 is nothing but 9. 1 into 9 it is nothing but 9. If the denominator it is p, power of a numerator base, it will be p minus 1. It will be p minus 1. Two more problems. Fourth question. 5 power 57. 5 power 57 divided by 29. 5 power 57 divided by 29. If the denominator it is a prime number, then it will become 2 power 28. 28 2s are 56. Another 1 power of 2 is remaining into 29. So these are nothing but 1. 1 into 2, it is nothing but 2. 1 into 2, it is nothing but 2. 1 into 2, it is 2. One more question. 7 power 49 divided by 17. 7 power 49 divided by 17. If the denominator it is 17, power should be moving in the cyclicity of 16. 7 power 16 by 17 it is 1. So 7 power 16 power 3 into 7 power 1 divided by 17. Divided by 17. These are nothing but 1. 1 into 7, answer is nothing but 7. 1 into 7, answer is nothing but 7. Very, very important problems. This is popularly called as Fermat's theorem. These popularly called as Fermat's theorem. Reminder 1. A power p minus 1 divided by p, it is 1. Please make a note. Numerator base value and the denominator both should be co-prime to each other. A and p are co-prime to each other. Denominator p, it is a prime number. Fermat's theorem is used when the denominator it is a prime number. I hope the introductory problems on Fermat's theorem it is clear to you. Next slide. Very, very important derivative of Fermat's theorem. We are going to solve it. Pay utmost attention to it. Pay utmost attention. I hope the idea it is clear. Now before that, any introductory problems are there? Fermat's theorem introduction which we have done. This one. Remainder 1, 52 power 30. So a power p minus 1 divided by p, it is nothing but 1. So 31, it is a prime number. So answer is 52 power 30 divided by 31. Answer is nothing but 1 based on the Fermat's theorem application. Already we did the basic introductory problems. 29, it is a prime number. So 28. 28 twos are 56. Another 17, it is remaining. 17 divided by 29, which is nothing but 17. Second question also, it is clear. Right. Third question. Before we solve the third question, let me see if I can create some very, very good questions on spot. Questions. 5 power, for example, 5 power 23 divided by 13. 5 power 23 divided by 13. Now, one is, in this problem, negative remainder seems to be the best method. Negative remainder directly you can use. 13 means power can be 12. 12 twos are 24. Coming back, doing backtracking, it will be cumbersome. Which power of 5? When divided by 13, I will get plus or minus 1. 12 11s are 22 into 5 power 1 divided by 13. 25 divided by 13. 13 twos are 26 minus 1. Minus 1 power odd minus 5. Positive remainder, it is nothing but 8. Positive remainder, it is nothing but 8. Very, very easy question. In fact, Fermat's theorem will take little more time. 13 means power is 12. 5 power 24 by 13, it is 1. Question is 5 power 23. So coming back, it will be little cumbersome. So for certain problems where the denominator, it is a prime number, negative remainder seems to be a very, very interesting logic. Very, very interesting logic. Now, for example, if it is 4 power 31 by 17, 4 power 31 by 17, 4 power 31 by 17. Use the same concept as third problem. Which power of 4 when divided by 17? I will get plus 1 or minus 1. 4 square, it is 16. Here directly you are getting it. So these nothing but 4 square power 15 into 4 power 1 divided by 17. 16 by 17 minus 1. Minus 1 into 4 minus 4. Positive remainder, it is 13. Positive remainder, it is nothing but 13. Positive remainder, it is nothing but 13. Now let us see. Suppose if it is 5 power 31 by 17. 5 power 31 by 17. 4 power 31 divided by 17 can be solved by using negative remainder. 4 square, it is 16. 16 by 17, it is minus 1. Directly you got. 5 square is 25. Remainder is 8. 5 cube, 125. 17 8s are 136. No, it is not giving you. So that is the reason here Fermat's theorem will be helpful. Here Fermat's theorem will be helpful. How the theorem will be helpful? Let us see. We will use, yesterday in Euler's theorem, we have seen the backward approach, or most popularly called as backtracking method. Backtracking means you have to determine the known, from that known you have to determine the unknown. 5 power 31 by 17. Because denominator it is 17. Denominator it is 17. Numerator can be 16. So 5 power 16 divided by 17, it is 1. These according to Fermat's theorem. According to Fermat's theorem. But according to the question, we require 31. According to the question, we require 31. We got 16. What is the multiple of 16 till 31? 16 twos are 32. So it is 5 power 32 divided by 17, which is nothing but 1. 5 power 32 divided by 17, it is nothing but 1. 5 power 32 can be written as 5 into 5 power 31 divided by 17 equivalent to 1. Listen carefully here, sir. From here, very good problem it is there. 5 power 32 we got. But according to the question, we need 5 power 31. So 5 power 32 can be written as 5 into 5 power 31. 5 divided by 17, 5. 5 power 31 divided by 17. I don't know x. When I further divide, answer does not change. Yesterday, the same kind of problem where the power of numerator is less than the quotient function. We used backtracking method. 5 by 17. 17 zeros are 0. Remainder 5. 5 power 31 by 17. We do not know the remainder, that is what we want. If I further divide, remainder does not change. If I further divide, remainder does not change. 5x, when you divide by 17, quotient is nothing but k, remainder it is 1. Dividend equivalent to divisor into quotient plus remainder. 5x equivalent to 17k plus 1. So 5x is nothing but 15k plus 2k plus 1. 15k plus 2k plus 1. 15k plus 2k plus 1. These are divisible by 5. These also divisible by 5. 2k plus 1. It is divisible by 5. So k minimum has to be 2. K minimum has to be 2. Why? Because 2k plus 1 equivalent to 5. 2k equivalent to 4. K is 2. K minimum 2. 5x is 35. X value is nothing but 7. X value is nothing but 7. Very, very good question. First we discussed the definition of a Fermat's theorem. Then we discussed how the negative remainder can also be used to get the answer very, very fast. Then we have seen the backtracking method. The notes will be very crystal clear. Each and every models that will come under a Fermat's theorem, everything will be discussed in detail. 5 power 16 divided by 17, it is 1. Multiple of 16 is 32. I want 5 power 31. 5 into 5 power 31 by 17, it is 1. 5 power 31 by 17, it is x. 5x divided by 17, it is 1. 5x is the dividend. 17 is the divisor. Quotient is k. Remainder, it is 1. Dividend equivalent to divisor into quotient plus remainder. 5x equivalent to 17k plus 1. 5x equivalent to 15k plus 2k plus 1. Divisible by 5, divisible by 5. 2k plus 1 should be divisible by 5. K minimum, it is 2. 5x is 35. X is nothing but 7. X is nothing but 7.